About 100 years ago, our understanding of the universe was incredibly limited. Most people believed everything existed within our own galaxy, the Milky Way. But in 1928, Edwin Hubble shattered that idea. He showed the universe wasn't still, it was expanding. This was a groundbreaking revelation. Then, in 1997, the Hubble Space Telescope discovered something even more surprising. The universe's expansion wasn't slowing down, it was accelerating. Something unknown, now called dark energy, was pushing everything apart faster and faster. Based on that, scientists estimated the universe to be about 13.8 billion years old. But now, the James Webb Space Telescope is challenging that timeline. There's a star cluster in the Milky Way called M92, filled with stars so ancient they seem nearly as old as the universe itself, maybe even older. That shouldn't be possible, because stars can't be older than the universe. Scientists used advanced simulations to estimate the age of M92, and the results left them uneasy. Could we be wrong about how old the universe really is? Enter the James Webb Space Telescope, the most powerful observatory ever built. It has shown us galaxies that formed just 300 million years after the Big Bang. But here's the twist. These galaxies are far too big and mature for their age. They look more like galaxies that should have taken billions of years to develop. Could this mean the universe is older than we thought? This puzzle, of ancient stars and too young to be so developed galaxies, is forcing us to rethink the age of the universe. One radical idea? The universe might actually be 26.7 billion years old, nearly twice as old as previously believed. If that's true, then our understanding of how galaxies and stars form could be fundamentally flawed. Take the Methuselah star, for example. Officially called HD 140283, it appears to be 14.5 billion years old, again, older than the universe. This challenges everything we know about stellar physics. Methuselah seems to be aging slower than expected, raising serious questions about our models of stellar evolution and the timeline of cosmic history. Another major issue is the Hubble Constant, which measures how fast the universe is expanding. The problem? Different methods give different results. Some measurements say it's 68 kilometers per second, (mpc). Others say it's closer to 73. This disagreement casts doubt on how we calculate the universe's age. Maybe dark energy, or some unknown force, is affecting expansion in ways we don't understand. The James Webb Telescope has also peered into the universe's dark ages, a time before the first stars formed. It's found fully formed, structured galaxies existing just 300 million years after the Big Bang. That shouldn't be possible. These discoveries are forcing some scientists to question whether the Big Bang theory, at least as we know it, is complete. This leads to some wild but fascinating theories. One idea gaining attention is the multiverse, the possibility that our universe is just one of many, each with its own laws of physics. If true, it could explain why certain galaxies and stars don't fit our current models. They may be influenced by physics from a neighboring universe. Another theory making a comeback is the cyclic universe. This model suggests the universe goes through endless cycles of expansion and collapse, big bangs followed by big crunches, over and over. In this view, some of the galaxies and stars we're observing might be leftovers from a previous cosmic cycle. James Webb has also spotted primordial black holes that formed shortly after the Big Bang. These could have helped early galaxies form more quickly, but they also deepen the mystery of how the universe evolved so fast. Dark energy, the force speeding up the universe's expansion, might not be constant. If it changes over time, that could explain why galaxies formed so quickly and why the timeline seems off. Meanwhile, at quantum scales, time itself might behave in strange, nonlinear ways, possibly shaping the early universe in ways we don't yet understand. All this means we may need to rewrite the story of the cosmos. It's not just about changing a number on a timeline. It's about uncovering deep, unanswered questions. What if the universe is far older than 13.8 billion years? What if it had a past before the Big Bang, or has a future beyond what we imagine. James Webb is more than a telescope. It's a time machine, showing us the ancient past of our cosmos, and raising questions that could redefine our entire view of reality. Every image it sends back pushes the boundaries of what we thought we knew. It challenges old assumptions, inspires new theories, and reminds us how much we still don't understand. Maybe our universe is just one story in a much larger narrative, one of many universes, or of one universe that never truly begins or ends. Whether it's dark energy, quantum chaos, or evidence of a multiverse, the discoveries are piling up, and so are the questions. Are we on the brink of a revolution in cosmology? As James Webb continues to explore, it's clear, the universe still holds secrets we've only begun to uncover. And the biggest surprises might be yet to come.